Hello everyone, welcome back to the chapter number 9 of Geometry Node series, and today we are going to talk about the Geometry Proximity Node. So a bit of shuffling in the chapters, but this is a really important stuff to talk before we get into the procedural stuff. First of all, I would like to wish a very happy new year to everyone. I hope everyone is having a wonderful time and wish you success in this year. So the Geometry Proximity Node is pretty simple in itself. The concept is not new to the Blender. So if you look at the modifier stack, there is something called vertex weight proximity. So what it does is basically the approximation of one object can give you an input which you can use to modify a certain aspect, either the modifier or instances or basically weight paint. Now the similar functionality we have in the geometry node. Since the geometry node has such a powerful interface, you can basically modify thousands of objects at one time and interlink things in between, go back and forth and use multiple inputs and do the math. So now this becomes even more powerful and is very useful tool for the motion designers and even for the procedural stuff. So let's say if you were making some sort of a scene, and in that scene around every house you need some grass and stones. So you can use the proximity node. You could say wherever you place the house in the closer proximity, you can use that input to scale the stones and the density of the grass and everything. So basically in this scene what's happening is the proximity of this grass is influencing these strands here, and the proximity of this sphere here influencing multiple things here, like the scale of these discs, the leaves and everything. So the closer it gets, the taller this grass gets, grass or wires, call it anything. You can see the scale is kind of increasing for these bubbles, for these discs, the rotation, the scale of grass, leaves and leaves density. So everything is being influenced either one thing or the other. So similarly for the things which are inside this sphere. So in the direction of the proximity geometry, in this direction, these small discs and wires are basically more dense and much larger. If I move this here, then you can see it's going to scale from the right direction. Since now we have grass on the right direction, it's picking up things pretty accurately, but the node in itself is pretty simple. If I go to the geometry node editor, let me just bring one geometry proximity node. In the node itself, there isn't much going on. You have a pretty straightforward 2 inputs, 2 outputs. One is for the target. In this case, the target is this big giant bubble thing, and the output gives you the distance and position. So distance is like a factor value, which is like a float, kind of like a gradient based on the closer and the further the object is. The farther it is, the less the influence is going to be. The closer it is, the stronger the influence is going to be. And you can even use multiple math nodes ahead of it, multiply and influence those the factors. And the position gives you accurate vectors of the surface of the proximity object. If you want to use those precise location of the vertices and the surface which is in the proximity geometry, you can use these vectors and it outputs the position of those vertices. So it will make more sense once we get into some practical examples. So before we proceed further, the sponsor of this series is Rendero. If you are a student or professional who is working on animation, editing, graphic design, or more of simulation, would like the flexibility to work remotely on powerful workstations, or maybe not really into investing into high-end machines and can't really afford a powerful computer, you can check out the Rendero. They offer cloud-based workstations which are good enough for any of the 3D animation, graphic design and video editing tasks. They have fixed monthly subscriptions. You can check out the prices on their website. We have done a very detailed video in the past comparing the speed, the benefits, the pros and cons, but for the prices, do check out their websites. They have updated the prices for the fixed monthly subscriptions, which are much more flexible to work with now. You can basically run cloud workstation 24/7 in a fixed monthly subscription. But in case if you're signing up for Rendero and if you see some sort of error, which I have been hearing a lot on the video comments, but in recent comments, I found out that in some regions, there is some problem if you are signing up on the Rendero. So due to the excessive demand and the limited capacity of AWS, the new registrations are closed in some regions. So if you get this error, I did talk to the customer support and it seems like it's a temporary issue and which will be resolved in coming few weeks. So you feel free to talk to their customer support and hopefully this problem gets resolved soon. So let's get to the tutorial then. Let me just explain the geometry proximity node first with a simpler example. So I'll just go to the geometry node editor and clear out my view. We are going to use a basic grid to explain this example. So all the short commands, all the stuff which I'm going to do here were discussed in the previous chapter. So if you have stumbled upon this chapter randomly, please go and watch the previous chapters for the things to make sense in the right order. So on this grid, I'm going to instance a few cubes. So let's say if we had 50 vertices, then 0.02 should be enough. So now we have a grid of cubes. So usually what we do is we bring a Musgrave texture or something and maybe combine XYZ so that if you want to separate out different dimensions. So we want this cube's vertical height to be affected by something. So usually just like we do work with the textures. So here you can see the texture is working on the Z height. So maybe if I bring a map range, I will be able to exaggerate these results. Something like this. So something like what we did in the chapter number 7. So this is what we do, right? But in this input, now instead of texture or math, we can use the proximity node. So let's say if I had one icosphere here, if I wanted to use this to modify this grid, I can do that by bringing a object info node first, just so that we have, let me just get rid of this Musgrave noise. So first we need this sphere inside our node network. So let's pick this one. Now we want geometry proximity. Yeah, geometry proximity node. So geometry proxy is in the geometry section. Yeah, I think, yeah, here you'll find it. So in the geometry proximity, we want to target this sphere that we have here. Yeah. So one thing to keep in mind when you bring a external object inside the geometry inside the node network, so it's going to reset the scale, location, and everything about it. So if you want to keep that scale, rotation, and I mean the one which you have in the scene, instead of resetting it, then use the relative. So what this will do is basically it's going to update based on the actual sphere that you have. So whenever you move it, your geometry node sphere is going to move as well. So let's say if I go to the viewport display and convert this to bounds, then this sphere, it's basically coming from the geometry node that is in perfect sync with this one. All right. So I'm going to use the relative and the influence, the distance which is coming out of the geometry proximity. We can now use the distance in the input of the scale. So something is going on here. At least we can see the effect, but it's not quite clear. So let me just make few adjustments here. Yeah, I'll hide these unnecessary things. All right, and make room for the node network. So let's get rid of this and keep things simple. So now we have the sphere working as proximity, but the effect is quite subtle. So let's bring a new fresh map range and try to work this out. So I'm going to just scroll some, do some lazy job and find some effect. So the closer it gets, it's giving me this the displaced cubes based on the shape of the sphere. So that's how simple the geometry proximity is. But fun part is, let me just bring a join geometry node so that we can see the actual sphere that we have here, right? So now we have both. Now the fun part is, it's not just the distance of this object. It's basically taking the distance of every point, every vertex on this surface. So in case if I bring one set position node or any modification I do in the shape of this sphere that we have, again, all these short commands, all these stuff that we are doing here, were discussed in the previous chapter. Please watch previous chapters. So I do keep getting these comments, like people are some confused sometime, probably because they haven't seen the series in the right order. So that's why I keep repeating this. If I bring one vector math, and let's plug this one into offset, and we want to push these vertices into the direction of the normal, multiply this with a texture which could be anything. Let's bring a noise. I really like this noise texture. It's like the mountain node which is in the Houdini. So yeah, and we can do math to, okay, this is strange. Multiply, should it be here? Yeah. So now you'll see the influence on these cubes. If I mute this set position, now this was a simple dome previously, sorry. Yeah, this was a just one curve, right? But now that we have a deformed cube here, the sphere here, you'll see multiple dents, much more detail going on in here. So maybe if I take this cube and make it 200 cubes, 0.01, yeah, now it's much more evident, I guess. 0.005 should be enough. And in the geometry proximity that we are getting, the output, we can where's the geometry? Yeah, this output. We can add another node. So now, not just the shape, if you bring a math node and just play with the different math functions, you will be able to bring out so many different results. Like, I really just like bringing in few different math nodes and uh, look at the different kind of effects that we get once I have some basic setup done. And you can also just bring a running number by typing one simple frame, maybe divided by 100, so that we have a running animation. There you go. You have a very simple, straightforward, good looking animation. Now keep scrolling and you'll get these cool effects. So exploring is geometry node is all about exploring. So you do something, you multiply different things with the math. Math is a really important part of the geometry node. Imagine you could do so much with math node just in the shader nodes. So now that you have actual geometry, I mean the possibilities are endless. So yeah, grid, and I think subdivision surface, I guess. There you go. So you have a very simple animation here. Now I'm just going to save this file. Now the technically this the explanation of the geometry proximity node is over here, but we are going to make something useful out of it, because the whole point of the geometry node is to understand the power of interlinking data from one object to other and mixing things up and to create more complex examples. So it's like the holding a cup and taking a sip. So that's why we are going to create something more complex with it, just like what you have seen in the trailer. For the beginners, I just wanted to give you a simple example. Now if you can keep up, let's do something useful with it. All right, I'll click a new file here and save this example. All right, so let's start with the final assignment then, and I'll start with a grid. And sorry about the screencast. I tried multiple plugins, but for 3.0 screencast doesn't seem to work. I'm not quite sure why is it happening. So, but very few short commands which are necessary, and we have already discussed in the very first chapter. So please refer that if you need to. So let's click geometry node, and I'll call this one geo proxy. Instead of this grid, I'll bring the grid that we have inside the geometry node so that we have much more control over it later on if you need to adjust anything about this. So I'll keep this field quite large, like 25 by 25. On this one, now we need to distribute few points. So first we are going to create some wires, and then we are going to use some random rotation with some texture, and then we'll spawn a few things on it. All right, and then maybe we can have some leaves on it, and then we are going to bring in a proximity geometry node and do the same thing what we have done here, spawn few leaves and wires on that as well. And then we are going to interconnect the influences of everything. So let's keep the density pretty low at this moment, and we can bring a curve line here. Let's bring one instances on points and plug this one into instances. There you go. Now I can make this tall, yeah, and let's make the background darker so that we have more visibility for the stuff that we're doing. Now for these lines, we can create some sort of animation. Let's bring a Musgrave texture and plug this one into rotation. So that way, when we animate this texture, we have this sort of sway animation, just like the grass field that we have. And for a running number, pretty simple thing. Let's just bring the frame number that we have. Just type frame, or actually let's make it divided by 200 so that we have a very slow animation. So yeah, we have our first step complete. So let's club all these into a group, a frame. Sorry, let's select all these, press Ctrl J and frame it. Let's call this one, give it some color and call this one grass field, maybe. Just give it any name. Now we are going to actually modify a few things about these strands with the proximity. Now all of these clones of the curve lines are basically instances of this one curve line. So any modification we do on one line is happening on every line. So if we make more instances on top of these, it's going to be a duplicate of one instance. So first we need to realize this. So we are going to bring our realize instances. Now everything is unique now. Basically you have, instead of a 1 1 1 line, now everything is considered as a one curve. The noise patterns or any instances we do here is not going to be repeated on every line separately. Instead everything will be considered as one. So for that we need the realize instance node, and this is what we discussed in the previous chapter number 7 as well. So do this, make sure you do this before you make any more modification or instances. Now let's bring one icosphere here, and now let's bring one object info node and pick this icosphere that we have. Now what we need to do is basically use the influence of this on these lines. For that, let's just bring a geometry proximity node and plug this icosphere in the target. So the idea is very simple. Just like how we do the displacement with the set position, we want to set position of the top part of this grass. Basically we want these points which are on the top to follow this icosphere that we have, to take some influence from this. So we are going to bring this set position right in this network and bring a node called endpoint selection, just like the previous chapter, the chapter number 8. So this is point 0, this is point 1, and in the curve, because we haven't resampled the curve at this moment. So for the start points, I'll choose none, no points, and for the endpoint selection I'll choose this one, choose 1 point here. Now let's see what happens when we plug this one into distance. Now if I select this icosphere, sorry, let's click on the relative. So we have some influence going on these endpoints. So if I deselect this, you can see everything is being influenced, and we don't want this to happen. So we want the grass to hold together at the roots. So that's why this endpoint selection is important. So now the proximity is basically adding into the offset. You can also plug this one into the position. So something going on at least. And if we choose the position here, as you can see, it's going to take the vector of the position of these closest proximity of these points. Top part of the of these curved lines is going to snap it here. So that's the difference in the distance and the position, but we want none of it. We basically want anything which comes closer to this sphere that we have to take some hint from this. Basically we want the best of the both worlds. So we want the influence and we also want this position. So some strands which are closer to this sphere will basically look at in this direction, and rest will just stand tall. All right, so for that we need to do some math. So let's do the math, and we are going to keep it simple, not really get into the calculations, but scrub a few numbers and observe things and makes a few decisions. So I'll choose a vector math node and plug this one into the position and bring one position node. So basically what we want is whatever is the existing position, let's just keep that. All right, so this gives us existing position of these points that we have at the top. Now if we multiply that with the distance, then you can see something is going on, and it's basically influencing everything. So we can control that. We can control that with a map range. Let's scrub few numbers and see if we can control this. There you go. So I'm not really doing precise math here. I'm not really good with that, to be honest. So, but I'm going to just make this work with the visual information that we have. All right. So I think a bit more tweak here. So at least the influence is visible, the distance. So we can see anywhere this icosphere gets closer to these grass kind of lines, the grass is moving up, becoming taller, and you can keep on tweaking these numbers further. All right. But the thing is, there's something not very great about this one. So these lines are moving up. The coordinates of these lines are changing, but these are not exactly facing in the direction of this icosphere. So basically the distance is adding into the multiplying the vectors of this the position of these points, but it's not really giving it the exact coordinates that we want. Basically we want these to point in this direction, something similar to this. So for that we would need the best of the both worlds, and to do that, let's just keep this as it is and change. We are going to take the existing position and subtract some information out of it. So let's change this to subtract now and multiply this, the distance, with the position here. I had to play around a lot with the numbers here, and there might be some other way to to do this. Maybe you can do this more effectively with some other math function or something else, but this is what I did. So do let me know in the comments if I'm doing something which could have been improved. So now we have the influence of this sphere gives us some direction. It's better than before. It's not really just growing taller, but it's also moving in the direction of the icosphere that we have. So that's great. It's a good start, and at least we have the basics working for us. Now what I want is now to add more stuff into this. Instead of just the grass, just the lines, what if we had some more details on top of this and more details inside this? So that's what we are going to do. So let's just sort this out. So one by one, we are going to just build it, and if I try to do everything simultaneously, for beginners, it's going to get slightly difficult to follow. Now, these wires that we have, first, let's just convert these to the solids. So curve to mesh, should be good for this. And curve circle, something of low resolution, and something of very little radius, 0.01 maybe. Profile curve, there you go. And just like what we discussed in the previous chapters, if you bring set curve radius and plug this one into the radius, so it's going to give you varying thickness based on the parameter of the curve. So 0 here, 1 here. You can invert this with the ramp if you want. You can simply flip the curve, but I would like to keep it as it is, so it's completely fine. Let's go to the solid view now, and let's keep the viewport dark. Let's hide this icosphere and bring one join geometry node, and where's the icosphere? Here. So we can plug this one in the, yeah, shift F to reroute, and we can also do some smoothing subdivision surface here. So let's keep it here for now, and we'll take care of this later. And this icosphere that we have the original version, we can set the viewport display to bounds. So yeah, that's a good start. Let's join these one in a frame, Control J, and name this curve to mesh. Let's keep sorting things out. Now let's make few more instances on top of these. Let's bring one instance on point, and let's bring one cylinder and plug this one into this. So now on every point of these curves we have these cylinders. Let's make these one more subtle. Let's first keep the curves into the joint geometry node so that we can see the both, and select this radius, keep it minimal. Sorry, I think I made some mistake here. So for these disk, to instance these disk, instead of taking this input of the curve, technically at this point it's a mesh, and there are multiple points. If I increase the radius, you can see at the top and at the bottom there are multiple vertices, and based on the resolution. So we don't want that. We just want one point, and uh, which is uh, at the top of the curve. So instead of taking this input, we are going to take this curve input, and let's plug that here. So with this, now we can use the endpoint selection node, and no starting point, only the ending point, and put it right here. Yeah, so this works. All right, so just a bit of correction. And now that we have the instances, let's arrange these into a frame with Control J and call these maybe disk instances, and maybe color this. One more thing is that when there are too many nodes, what I usually do is, if possible, try to arrange it in this hierarchy like how it is in the scene. So at the bottom we have the ground plane. On top of that we have the lines and everything, and so I'm going to arrange that in the same way so that I can at least quickly make some navigation is easier. So the discs are on top of the lines, so I'll put that here, and the sphere is right here, the subdivision surface, and more things about the sphere that we're going to add, I'll put that here. All right, so it's completely optional, and also I'm keeping this chapter a bit slower because it's a much more complex example for the beginners. So yeah, and now the exact same thing what is happening with the influence, the lines are growing. We can also use this influence for the scale of these disks. So let's say if I go to the sphere proximity and plug the distance data and put that into the scale of these instances, then you'll see it's going to affect the scale. But this is not the result that we want. Instead, I'll use the map range and plug that here. So anything which is closer to the icosphere should grow bigger with this grass, and rest everything should be small. So I'm just going to scrub it, find something useful. Doing some lazy job here. Yeah, something like this. And if you want, you can keep the s- the influence on the rest of the things a bit more visible instead of completely disappearing. The I mean, it's totally up to you. Just make some visual calls. And the same thing we are going to do for the rotation. So I'll bring one node called align Euler to the vector and plug this one, and this one is into the vector, I think utilities align Euler to the vector. So plug this one into the rotation, and I'll use the same thing for the rotation here. So maybe we can bring one something else. Maybe let's try the normal node and plug this here so that we have some information from the normals, just at least adding into the rotation of it, and everything is not really flat. So it's not really precisely done, but at least we have some visual variation going on. Now we are going to distribute a few more things. Let's distribute points on faces and put it here. And in the input, we are going to bring the mesh that we have for the curves. So just plug this one here, and on this instances on the points, plug this here. And in the instances, I'll bring one object info node, and I have a very simple leaf. If you look at here, I have this basic geometry. So this is what I'm going to use for instances. So I'll plug this one into instances. So let's see what we have on these lines. We have some points scattered, and then we have these leaves scattered on top of this. But we don't want leaf everywhere. So we only want leaf to grow in the approximation to where this icosphere is. So for that, what we can do is we can scale these things up and down based on the approximation that we have. So again, let's bring the same geometry proximity from here, the distance data, and plug this into the scale of the instances of the leaf here. And let's combine these into a frame, and let's give this a green color so that we can understand the node network. So now the leaves are like too big, and we don't want that. Map range should be able to fix that. So let's see. I'm going to just scrub few numbers again and try to make this work. Something is wrong going on here. Yeah, sorry. I didn't really connect the instances on points. So let's first plug this one into the join geometry node. And sorry about that. Let's bring a fresh map range. Let's zero everything out first. So maybe we want something like, I find it a bit tricky to work with a map range when you are not actually sure of the exact numbers that you're looking for. So, but scrolling and working out maybe sometimes the negative values, positive values. So not going to be able to give you a hard advice on that one. So yeah, something like this. At least the leaves are growing, but we need some randomization in the rotation. So let's bring one combine XYZ and plug this one into the rotation. We just want to influence the Z rotation and do that randomly. So random value should be fine for that. Sorry, maximum random value, something like this. I wish we could change the colors in the geometry node for the viewport display. So right now it gives you just a flat color. So I wish that was possible. And if possible, let me know how you do that. So now if we move this icosphere closer to these geometries, the disk is growing up, the leaves are growing up. So this looks fine. This looks fine for abstract scene like this. All right, so we are very close to the finish, and then after that we are going to just fine tune a few things. Now let's go to the icosphere. First, what we want to do is scatter a few things inside this one. Let me just select this icosphere that we have and align my cursor to selected, and then bring one more icosphere here. Scale it down like this. And call this one small icosphere. Then I'm going to just parent this one to the original one so that when I move the bigger one, the the small one moves as well. Simple stuff. Let's select the graph and now let's bring one object info node, put that here. And in this one, I'll choose the small icosphere and then distribute points on faces. Sorry, let's click on the relative. Yeah, let's make it 40 points and yeah, this should be fine. Now we are going to bring one instance on the points, and for the instance, we can use the curve line again. Exactly the same thing that we did for the grass field. And then we can plug the normals into the rotation so that based on the normals, we are getting this rotation. Now, right now, I think it's not really working properly. So the rotation doesn't know in based on the normal in which direction you want to rotate. So we can say just work on the z direction. Sorry, I think work on the vector auto. Yeah. So that takes care of the rotation. You can hide this one. You don't need to look at this again. And you can hide this one as well. So just keep sorting things out. Now we need to convert these lines into the mesh again. And since we have already done that here, what we can do is we can copy these nodes, or we can just Control G. So that makes it a node group. So let's call this one mesh to curves to mesh. Now we can copy the same node with a Control D and plug that right here. It will do the exact same thing. So you don't have to work on multiple nodes again. So that's quite handy. Now the scale of these lines, we want to influence that with the field, the grass field now. So first of all, let's just go to the join geometry node and plug everything in the join geometry so that we can see the both. We can see the lines, we can see the grass field, and now we want to do the opposite thing. So instead of sphere influencing this, we want these to influence the size of these lines. And for that, what we would need is geometry proximity. Let's plug this here. And what we want to use for the proximity is these vertical lines, the solids that we have. You can use the disk here, but I think it's safer for this example to keep these lines for the proximity. So as soon as these lines get closer to this mesh, that based on the distance, it's going to decide the scale of these lines. And again, to exaggerate this, we would need some map range. Try to figure this out. So based on the distance, we want these lines to get maximum maybe this tall, and then maybe try to fix the minimum number, something like this. So if I move the icosphere into this direction, yeah. So when it gets closer, I think we need to tweak it further. Maybe if we bring one more color ramp here, then we might be able to add into the contrast of the ups and downs. Yeah, so you can see it's working. The lines grow as it gets these get closer to these surfaces of the lines. So I think more or less this is done as well. We can again plug these into one clean frame and call these one into lines inside bubble. And now similar to these disk, we need a disk on these lines. So for that, let's bring one another instance on points. And for these, we want to use the wires. So distribute points on faces and curve lines. So before converting it into the mesh, we had this wires, the curve data. So let's plug that one into the points and endpoint selection again. No starting point. We only want the ending point, and the cylinder that we had earlier. Similar to that, we should plug this into the instances and plug everything to the join geometry node. Now we have these disks, and exactly the same thing we can do. We can use the influence on the scale of these disks. So without this, we had this. And if I plug this one into the scale, let's see what happens. Actually, instead of this, we can keep it separate control. We can control it separately. Let's plug a fresh one here and map range it differently, I mean separately, so that at least, yeah, so that we have more control on this. If we want to exaggerate this one, yeah, something like this. So I'm going to control J this and make it a frame, color this one. Let's keep things fancy. All right, so quite close. Now the final thing, what we need is we need some wobble into this icosphere. There it is, the subsurface surface that have been lying here for quite some time. So now let's set position. We need to displace this. So set position node here. Now all we need to do is bring one vector math and push these vertices into the normal direction, multiply, and bring one noise texture. Scale this down, maybe 0.1. Now bring a value node here and do the same thing for the running number and make this one into 4D noise. Plug this one into the W so that we have this movement in the noise. So it's going to be very subtle. We don't want to keep it too obvious, but we are going to manually animate this number when it gets closer later on when we animate this bubble. So don't worry about that at this moment. So let's select these, scale these down, and Control J and call this one something, maybe wobble. And then the last thing that we need is distribute points on faces, and we want to take this the bigger one, icosphere. Sorry, let's take the same input and plug that into the join geometry node so that we have original form of the icosphere. And now instances on the points. Let's bring another icosphere and plug that into the instances. Now for the scale of these icospheres, we are going to use the influence that we used on the, since these are quite closer to the lines that we had, sorry. Yeah, since these are quite closer to these disks that we have inside, so we can use the influence that we were using to scale these disks up and down and plug that into the scale. Right, so I think we need to tweak this with the map range. Let's bring another map range. Sorry. Plug this here. So now you can adjust this based on what kind of look you're going for. But I think this is fine for us. And now let's bring one plane, put it on the ground, and let's animate this with a simple animation. So on the frame 0, I'll keep it here. Press I, location, rotation and scale, and slowly bring it into the scene. I think we would need to tweak this. The values or influences right now, these are too aggressive. So let's not worry about that. Let's just animate this one first. Location, rotation and scale. And I think it's fine. And maybe you can just drag it a bit more further here and give it some random rotation. Now that you have the animation, now you can start working on the more balancing out the things. So these are bubbles. So let's just control J this and make it into bubbles. Now the main strands, this grass is basically growing too tall. Now if we change any of this, you can see all of that, whatever is inside, outside, is getting influenced with the is getting influenced because all of this is interlinked. So honestly, I think the bubbles are too big. I can just tweak these and make these a bit smaller. Sorry, something like this. And the animation, the original animation that we have, the noise pattern which is making this grass move, that can be slower as well. Yeah, something like this. Let's see what's going inside. Let's just uh, shift click this. Yeah. So just to isolate this, if you want to have a closer look, Shift Alt and click on the node networks. Yeah, so these are working fine. These are working fine. Now you have this node network, and after this point, what you need to do is just plan out your shots, fine tune these parameters that you have. Now that we have the full setup and everything is working fine, but for the final sequence, what I did was I made multiple copies of the scene. So you can do that from here, or you can just save your scene with a different version. As you can see, I have shot 2, 5, 3, 1, 2. For the different shots, I used different density of the grass and the different part of the scene. Few things worked fine in the close-up and a few things worked fine for the distant shot. For instance, if I just go to the distant shot, now here I find the grass, the strands of the lines are not really dense enough. So what I did was increase the density of the grass field here and made it into 10 or something, like maybe 5. For this shot, it looked much better. So yeah, something like this, 4 maybe. So now after this point, you can start tweaking things for every shot, for like what is working, what is not working. And usually one setup for multiple shots, I don't really find usually that working. So for the distant shot, I used more density, and for the close-up shot, something like this, I used much lesser grass strands, because for this example, if you see, there is so much clutter going on here and I can't really see the inside lines, and the influence of it is not quite visible. So instead I wanted a very few samples of the grass, so that the influence, the direction is much more visible. So what I did was just reduce these to zero point 0.1, and now you can see there is much more room here for the visual. It's much more breathable. And for the for the lines which are inside the bubbles, I tweaked a few things. First of all, I brought a math node, because the existing values were not really working fine, because there were very few samples of the grass here. So the density, since the density has decreased, I'll have to bump these values up. So now you can see it's much more evident in the close-up shot because we have like few points. This is on the left, this is on the right. I wanted to exaggerate this, the direction, the fall off and everything for the macro, for the close-up shots. So this is what I used. Let me just hide this bigger sphere here. So this is what I used for the close-up. For the rest of the shots, I just kept on fine-tuning few things for depending on the requirement of each shot. So density 1 here, and on one of the shot I wanted to focus on the size of the disc. So for that what I did was just adjusted worked on the size of the disc, basically the influence of it, the disc influence. And I didn't wanted the disc to be so big at the start. Instead I wanted these to grow only when it gets closer, just to exaggerate this one, something like this. So these are not the exact numbers which I used for the final files. So I will be leaving the files on the Gumroad if you want to have a look. So the numbers may vary, and these are not exactly the same numbers, but it's exactly the same setup. The only difference is the values here and there. And I spent much more time to perfect things. You'll have to make few calls on your own if you are just trying to get things right. And similarly for the close-up shot, I think I had to tweak these numbers as well, something like this for the sphere bubble. So I think you get the idea. And all you need to do is, after this point, start assigning the materials. So let's create few materials. And so for the rendering I used cycles, and for the materials I used disk material. I'll show you the material setup in a bit. And this one for the just bring the material assigned or the set material node. Let me just shift F this and reroute this. So it's a lot of mess here. I'm just going to disconnect and arrange things in much better way. Let's plug the material for every network. Control J this. You can select all of these nodes, SX0, to scale these into the X direction. So it basically works like a line. I usually reroute right before the materials if there are like really long wires for the network. So in case if you need to disconnect something, then you won't really have to go back again and then bring that network. So you can simply drag it from here. Now I'll have to check it one by one. So this one is for the inside disk. So I can just click on the disk here. For the bubbles, I think I needed sphere bubbles. And for the wires, I think I need the wires. So that's it, everything is done. Now let me just give you insight of the material, which is pretty basic. You know, I love working with the basics. I'm not really much into the complex setups. I like to spend more time on the compositions, on the editing and everything. Gives some meaning to the visual instead of working with the very complex. I mean, I sometimes do work with the complex ones when the need arrives, but for the tutorials I like to keep it simple. Now that we have everything set up, let me just give you an insight of the materials. So I'll just bring up a different file. So here I have the main file, which is arranged in the similar way. It's exactly the same. You have the ground, you have the sphere proximity, and everything is exactly the same. So I'll just leave this file on the Gumroad, and you know how to get these files. All these files and the previous files are there on the Gumroad if you need one. For the shader, let's just go to the shader editor. For the environment, I have a very simple sunrise.exr, which comes default with the Blender. And for the rest of the shaders, for the disk, I used magic texture just to bring some colors into the base color and transmission variation in the transmission. So very simple stuff. And This is the material for the disc, and for the wires I have flat white wires, and these are metallic, so everything is reflective. And for the glass sphere, I have two versions. I'm sorry I didn't clean this up. Yeah. So for the glass, I have two materials. So for few shots, I used this material, which is basically using some noise texture on top of the glass into the imperfection, and in the in the base color, I have this basic gradation going on with the magic texture. And for other shots, for the close-up shots, I used a basic glass BSDF. So I just wanted, yeah, a flat glass look, nothing else. So no colors, nothing. And instead of color on the base color, I used volume absorption, a bit of tint of the pink, and very less density. Yeah, that's about it, guys. And there's nothing much into the scene. And for the lighting setup, I used very basic lights, the area light pointing into one of the direction. Wherever the background was needed, I used this white wall, and in one of the direction, I used this light. And the HDRI is working for the rest of the stuff. So let me just show you how it looks in the render. I kept the colors very light and not really too saturated. And for few of the shots, I used this. I think for this shot, this was meant to be for the top shot. So I think if I increase the density to 5 or 10 or something, then you'll be able to see more colors. Yeah, so this was for the top shot, and as you can see, there are very light colors which are coming from the magic texture, and I wanted to keep the scene very light and only use colors where the proximity is going on. So, and other thing is there is a light right inside the sphere. So if I select the lights, I think I have this icosphere. Inside this, there is a light which is linked to this icosphere. So basically this light is kicking in from the inside. So I wanted to have some strong saturation inside the sphere and some lights instead of dark materials. And for some of the shots, I also used a dark environment. For that, I simply turned off the HDRI and all the lights and only kept this outside light visible. So let me just show you other scene. So for this scene, I used yeah, for this scene, I used much less density in the. Sorry, this one is not the cleaned up file. So much less density in the wires. So there is a very little grass field, and in the shader editor, I think for the glass for the glass sphere, I have this version of the glass which I'm using. Yeah, so flat glass material. For some shots, I played around with the IOR to add some distortion because there's a distortion going on in the sphere, and I wanted to use some exaggerated value in the IOR so that these wires look much closer or much in the solid view. You can see these are much far from the this sphere, but in the rendered view, I'll be able to scrub these values without having to worry about the sound. Let me just disable the noise. So as you can see with the IOR, I can just bring these distortions, I mean the refractions closer. It's like the magnifying glass. That's about it for the setup. And one last thing which I would like to discuss is the establishing shot, which is there. In this, when this icosphere gets closer to these lines, there is a wobble, this wobble. So for this, I simply scrubbed the values of the distortion, the Musgrave texture. Yeah, these lines. So in the sphere, we used distortion with the noise texture. So when this gets closer to the lines, I simply animated these lines. So if I go to the timeline, right before when this lands on top of the on top of the field, right here, when it touches the lines, set the key and go slightly further, and then try to animate this value. That's about it. So you'll have to play around a lot with the values for the each shot, yeah, and work out your sequence. So that's about it guys for this scene, and I hope you were able to follow along, and I've kept it pretty slow, and I didn't try to rush anything, and I try to keep it as clean as possible. And if you are having trouble navigating such a big map of the, I mean, it's not too big. Just in case for beginners, if you're having too much trouble, instead of scrolling in and out all the time, what you can do is split the window and keep this one for the overview of everything. And in this, if you select anything, just come here in this view and click on the and just hit the dot key on the number pad. So basically, which zooms on the selected. So every time you have to jump anywhere else, just bring your mouse here and then go back. So this works like a navigator. So one for the close-up view, one for the large view. Rest everything is all about the visuals, all about the editing, and the materials are simple. The sequence is quite simple. Just find your music, find your style, and just give it time. Once your setup is done, once everything is done, just try to fine tune everything. Think of a sequence, try to storyboard a sequence. Let's say if you have a uh, let's say if we go to the 2D animation, and you can simply plan out your sequence. You can just try to storyboard your sequence. Let's say you have 4 or 5 shots. You can maybe think of what could be the first shot. So first shot is usually the establishing shot is a great way to start a sequence. So you can keep a long shot of the field where everything is seen from the distance, and as it touches the grass, then you come to the close up, and then you decrease the number of strands and only work on establishing a visual which says that these lines are interacting with this sphere, and inside of this is interacting with this. So less dense grass and more directional fall off will be seen. And then after that you work on the multiple shots, maybe one moving from the top, sorry. Then you can establish multiple shots, maybe one from the top and one could be right inside the sphere. You could just focus on what is inside the sphere and what could be the view from inside these discs. I mean, just making an effect is not going to get you anywhere. So you'll have to make some sense out of it. At the end of the day, it's something. It could be motion graphic. It could be an abstract. It could be a visual installation. Anything it could be. So just work on a sequence and just try to establish a few things. Put few cameras. Find the right view, maybe camera to view, and just try to explore different views here and there, and work on sequence. And that's about it. Keep things clean, keep things arranged. I leave all these files on the Gumroad, and all these files and the previous files from this series are on the Gumroad for you to if any one of you is looking to explore these files. I'll be adding more files. Whatever is yet to be added into this series, all those files will be available on the Gumroad as well. So if you get this now, you'll get all the future updates for free. So in case if you want to explore more with the files, really want to look into the render setups and everything, then you can just get the files. Although I've explained everything here, but sometimes you would want to reverse engineer the file. So for those, click on the link below right in the description, and I would love to see what you make with this. In case if you're following the same scene or if you're making something else with it, there are many possibilities. I'm pretty sure you can come up with your own visual, own style, and something much more dynamic than this. And do tag me on Instagram with CrossMind. I would love to see what you make with this one. Do check out the playlist section and playlist for this series. All the previous chapters are right there in the correct order for you to access. That's about it. I'll see you guys in the next chapter. This has been a very lengthy chapter, and I'll see you guys in the next chapter. I think probably we will be talking about the raycast, which is another very powerful node for procedural setups and motion graphics. So stay tuned. I hope you guys are enjoying this series. Happy New Year. Take care. Bye bye.